What is the difference between a lifter and a slider? Lifters and sliders are two types of components that are commonly used in injection molding. Both are designed to provide movement within the mold and to help create the desired features on the molded part. However, there are some key differences between lifters and sliders. And understanding these differences is important for selecting the right type of component for a particular injection molding application. Lifters are typically used to create undercuts in molded parts. An undercut is a feature that extends beneath the surface of the part and is not accessible from the outside. Lifters are designed to move vertically within the mold and can be used to create features such as threads, holes, or other types of recesses in the injection molded parts. A lifter is a mechanism that is used to create a moving or removable feature in a molded plastic part. It consists of a pivoting or sliding arm that is attached to the mold and is activated by the injection molding machine as clamping mechanism. When the mold is closed, the injection molding lifters are held in place. But when the mold is opened, the lifter is free to move. This allows for the creation of moving features such as hinges, latches, and other types of interlocking features. Several types of lifters can be used in the plastic injection molding process, including straight lifters, angled lifters, and multi-level lifters. Straight lifters move up and down in a linear fashion, while angled lifters are designed to move at an angle. Multi-level lifters are used to create multiple undercuts in a single molding cycle. Sliders are mechanisms that are used to create removable features in a molded plastic part. They consist of a sliding element that is attached to the mold cavity and is activated by the injection molding machine as clamping mechanism. When the mold is closed, the slider is held in place. But when the mold is opened, the slider is free to slide along its track. This allows for the creation of removable features such as snaps, tabs, and other types of interlocking features. Like lifters, several types of sliders can be used in injection molding, including single-stage sliders, double-stage sliders, and tri-stage sliders. Single-stage sliders move in a single direction and are used to create simple slides or grooves on the molded part. Double-stage sliders can move in two directions and are used to create more complex features. Tri-stage sliders can move in three directions and are used for even more complex features. One key difference between lifters and sliders is the direction of movement. Lifters move vertically within the mold, while sliders move horizontally. This means that lifters are generally used to create undercuts, while sliders are used to create slides or grooves on the surface of the injection molded parts. Another difference between lifters and sliders is the type of movement they provide. Lifters typically provide a single axis of movement, while sliders can provide multiple axes of movement. This means that sliders are generally more versatile and can be used to create more complex features on the molded part. Lifters are typically more complex than sliders, as they require more precise movement and control to function properly. Sliders, on the other hand, are generally simpler mechanisms that require less precise movement and control. The choice between using a lifter or a slider in a molded plastic part will depend on the specific requirements of the part and the desired features. Lifters are well suited for creating moving features such as hinges, while sliders are well suited for creating removable features such as snaps and tabs. Conclusion. In conclusion, lifters and sliders are two types of components that are commonly used in the plastic material injection molding manufacturing process. Lifter pushes are used to create undercuts in molded parts and move vertically within the mold, while sliders are used to create slides or grooves on the surface of the molded part and move horizontally within the injection molds. Understanding the differences between these two types of components is important for selecting the right component for a particular injection molding application.